Lesson 9.3, Properties of Rotations. Lesson 9.3, Properties of Rotations. Example 1, Graphing rotations. To rotate a figure in the coordinate plane, rotate each of its vertices, then connect the vertices to form the image.
All right, let's try one last movement around the plane, if you will, one last transformation. So I'm given this triangle, x, y, z, and here we're supposed to graph and find the coordinates for the vertices of the rotation. Now, rotation means that we're going to take it and kind of pivot the object somehow. And let's see how. So we're going to rotate this triangle, x, y, z, 180 degrees clockwise around the origin. So what that means is you think of the origin as kind of like the center point, and now we're going to take this thing, and of course, you know, clockwise means that we go in this direction, and we're going to go 180 degrees, which means kind of halfway around. And what happens? Not so easy to see what happens, but let's just try it. Actually, I've got a movable triangle right here that's exactly congruent, so you put it right there. And then what we do is, you imagine like putting a pin or something literally right there at the center, like that. See that? Boom. And I put my finger there, and now 180 degrees. That means that I go, let's see, it's kind of neat because you can really see the movement. It's kind of interesting. This, by the way, is just 90 degrees. That's 90 degrees. That's sort of halfway. But we're going 180 degrees clockwise around the origin. And then look what happens. You get right to here. Yep. And there we have it. So you can see exactly where the figure is. Kind of interesting, actually. Not so clear. Let's see if we can actually label this correctly. All right. So I've got to label an x prime, a y prime, and a z prime. The way to do that, by the way, is maybe just take the point and kind of follow it. So here, that's x, and where does that go to? That's the highest point. So when I go way over here, it's going to be the lowest point. So that's going to be x prime. This point is the furthest point to the left, which means that when I rotate it 180 degrees, it's going to be the furthest point to the right. So this is going to be the z prime. And therefore, this better be the y prime. Let's see. It's close in here, y prime. In fact, just thinking those thoughts actually helps me with the rule that will, in fact, produce the coordinates, even without graphing it. It's up here. So what we do is we take the coordinates, and what do I want to do? Well, here, since I'm actually rotating around the origin 180 degrees, notice what happens. That not only does the x value change sign, but the y value also changes sign. So the x value flips and the y value flips. And so what I have to do here is I have to multiply both the x and the y value by -1 in order to change the sign of each. So the corresponding value for x prime would be, coordinates would be -1 times -3, and then -1 times 4. Because, by the way, the coordinates of this point, you can see, are -3, 1, 2, 3, 1, 2, 3, 4. So there's that, x. And what does this give me? This gives me an x prime having coordinate -1 times -3 is 3, -1 times 4 is -4. Does that check? Let's see. 3, 1, 2, 3, 1, 2, 3, 4 down, so that's -4, it checks. And this goes on. Y prime would be -1 times this -1, -1 times 0. Again, I multiply both coordinates by -1 to do that 180 rotation around the origin. So I see y prime has coordinates 1, 0. Does that check? Yeah. 1, 0. There it is. And then finally, for the z prime, same rule. -1 times -4, -1 times 0, and we see that z prime is going to be this time 4, 0, and that's exactly what we see here, 4, 0. And so you can see we have it. We've actually found the coordinates, not just by reading off, because this graph might not be perfectly accurate, but just using the facts we're given and reading off the coordinates of the original geometric object, in this case a triangle, we were actually able to rotate it and use a rule to find the coordinates of that rotation. Congratulations on moving things about the plane. Have lots of fun with it and enjoy finding those coordinates via the rules for yourself. I'll see you soon.
Okay, adding to the tutorial. Notice our rules we have here for rotations. Type of rotation, if it's a 180-degree rotation, then we multiply both coordinates by a -1. Multiply both coordinates by a -1. So x and y becomes -x, -y. If it's a 90-degree rotation clockwise, 90-degree rotation clockwise, we multiply each coordinate by -1. Excuse me. If it's a 90-degree rotation clockwise, we multiply each x coordinate by -1, then switch the x and y coordinates. So our original is x and y. Then we multiply the x by a -1, so it becomes -x, and then we switch places. If it's a 90-degree counterclockwise, we multiply each y coordinate by a -1, then switch the x and y coordinates. So when it's counterclockwise, we multiply the y by a -1, and then switch the place of the x and y. So the y becomes first, negative, and the x is second. Now also add this in. 90 degrees counterclockwise is equal to 270 degrees clockwise. Once again, 90 degrees counterclockwise is equal to 270 degrees counterclockwise. So once again, these two are equal, and these two will follow this rule. XY, you make the y negative, and then you change positions. So 90 degrees counterclockwise is the same as 270 degrees clockwise. All right, now for those of us who don't understand clockwise and counterclockwise, I attempted to make a circle going around the coordinate plane. Now don't forget, each section here is 90 degrees. So 90 degrees, 90 degrees, 90 degrees, 90 degrees. So here to here is 90 degrees. Here and here, 90 degrees. Here and here, 90 degrees. Here and here, 90 degrees. So if I said a rotation 90 degrees clockwise, that means you're here and you're going in this direction 90 degrees. If I said 180 degrees clockwise, you're going from here to here. That's 180, 90 plus 90. If I said 270 degrees clockwise, you're going from here all the way around there, 90, 90, 90. And then if we said 360 clockwise, you're going from here all the way around back to where you started. So 90, 90, 90, 90, that gives you 360. All right, so if I told you 270 degrees counterclockwise, that means you're not going this way. 90 degrees, 90 plus 90 is 180. 180 plus 90 is 270. See that? That's 270 degrees counterclockwise. That would be the same as going 90 degrees clockwise. So 90 degrees clockwise, 270 degrees counterclockwise is the same. And that's why 270 degrees counterclockwise equals 90 degrees, 270 degrees clockwise equals 90 degrees counterclockwise. And it follows this rule.